Alright, so this is an example question I'll be talking about when you are because you ask me, hey, how do you take out things? Okay, so the things which are your terms, right? I'll be sharing with you today in this video on how are we going to take them out. Alright, and I'll write the tips here as well so that you'll know what I'm talking about. Alright, so this question here, differentiate the following with respect to x, where y equals to 3x plus 2 to the power of half and 5x minus 1 to the power of 4. So my first question to you is, what kind of differentiation is this? This is your product rule, right? So your product rule, do you remember this formula where you have d over dx? Hold on. Let me write that in a different color for you. So remember, you have this d over dx uv. So this is a u dv over dx plus v du dx. Alright, so that's your uv. Alright, as you have learned in syllabus code number 4049. So yep, this is how your product rule should look like, and mind me, I'll shift it to this side, to the top here. Alright, so we know that it's a product rule, so we'll apply this d over dx uv, where we copy u and we differentiate v in terms of x, and we copy v and we differentiate u in terms of x with respect to x, I mean. Alright, so now let's identify where our u and v are. Alright, so this is your u and this is your v. Alright, so actually for better clarity, I will kindly change the letters as well, so it will be easier to identify. Yeah, so this will be uv Alright, I hope it looks clearer now. Alright, so yeah, let's start with our product rule. Alright, so before I start our product rule, always remember, let's start with our values first. Let's do your du over dx. And what kind of differentiation is this? When we differentiate u with respect to x. This is our chain rule, right? Chain rule. Alright, so when we look at chain rule, power number come down, power number minus 1, and we differentiate the inside bracket. Alright, I will go slow with you here. So what means I will go very slowly so that you will not miss out. Alright, power number come down, I bring the power number down, right? And now power number minus 1. So when I power number minus 1, half minus 1, I press the calculator, I get a minus half and a power here. And then when I differentiate the inside bracket, I get a 3. So overall, this will be written as 3 over 2, 3x plus 2 to the power of negative half. Okay, leave it like that first. Alright, don't need to worry so much. And now let's write our dv over dx. So we differentiate v in terms of x. Chain rule again, power number come down, power number minus 1. So 4 minus 1 is 3, right? And we differentiate the inside bracket, we get a 5. Alright, why 5? Because remember, I'll explain for 5 and 3, they are similar, just that the numbers change. Okay, so why 5? Yeah, because 5x, right? There's an invisible power 1 here. Okay, so this will mean that what? This is basic power rule. So our basic differentiation, that means power number come down and your power number minus 1. And we know that this is a 5 bracket 1 x power 0. X power 0 can be interpreted or can be written as 5 bracket 1 bracket 1. Why? Because x power 0 in indices is equal to 1. And therefore 5 times 1 times 1 is just 5. Okay? And that's why when you differentiate, you get 5. Clear so far, yeah? Okay, if not, just ask me any questions, okay? So, when we do this, we get what? What do we get? We get a 25x minus 1, 3 power cube. Alright, so now we have your dv over dx and your du over dx. Let's start to apply and let's ask ourselves this question. Is it in the nice form to differentiate? If it is in the nice form to differentiate, let's start to differentiate. Alright, so we know that what? dy over dx. Let's sub in our u and v. So uv, right? So let's go. Alright. So u will be, okay, I will write okay, I'll just write in green. Alright, so u, we have 3x plus 2 half, and now your dv over dx. So your dv over dx will be 20. Actually, I can write like this, so I will show you. Or I can write a square bracket 20. But I just worry you confused, so I'll write it all like that, because in a way you're all multiplying together. Okay, so when you write already, right, you add a plus sign. Okay, when you add a plus sign, now we write your v and your du dx. Okay, so what's your v? Your v will be 5x minus 1, 4. Your du over dx will be your 3 over 2, 3x plus 2 minus half. Okay, so when you do like that, right, now let's start to simplify. But right now, can we simplify or not? Actually cannot. Okay, so let me give you extra information. Number one, this is your first term, and then your next term will be here, yeah. Okay, so purple, so basically in between the plus sign, this is your first term and this is your second term. Alright, so yeah, can we factorize, and how do you want to take out, right? So I will go through step by step over here. So how you're gonna do is like that. Okay, let's look at constants first. Okay, I'll write down some tips, yeah. So number one, when we want to take out things, we will always look at your numbers. Look at constants. Okay, I'll use a bit of math vocab here. So constants just mean numbers. Alright. And then second, number two, look at your x terms or unknown terms. Okay, so when you look at your x terms and unknown terms, so let's look at constants. Alright, what are your constants, or what are your numbers in this case? Okay, your numbers are 20 and 3 over 2. Is there a common between them? And 3 over 2 is the same as 1.5. Okay, so is there anything common? Like, is there a common factor? Don't have, right? So leave it, right? Alright, so now let's look at your x term. So usually for me, when you look at your x term, one more thing to add. Sorry. When you look at your x term, right, one more thing to add, I will always look at positive whole number powers. Okay, you might want to take this down, yeah. Okay, so these are your two steps. So positive whole number powers, whole numbers, that means what? That means I don't want any, no fraction, no decimal. But usually it's fraction. But the thing is, right, half is the same as 1 as 0.5, right? So yeah, I'll just write no fraction, no decimal. But usually it's just no fraction, so I'll just write no fractions for now. But if you want, I'll also write no decimals. So I will look at positive whole numbers. So I'll maybe highlight over here. Okay, so whoa, okay, so right, when you look at your positive whole number, that means I don't want to see any fraction, I don't want to see any decimal. I want to see whole numbers. Like what? For example, I want to see like 1, 2, 3, 4, 5, 6, 7. Okay, and maybe 8, for example. I want to see these kinds of numbers. I don't want to see any decimal. Like what? I don't want to see, or fraction, I don't want to see half, I don't want to see 3 over 2, I don't want to see 4 over 5. Alright, I'll just look at the numbers. Clear? Okay, so Let's now start, okay? So look at positive whole number powers. So what are the positive whole number powers? No fractions, no decimals. Remember that. Alright. Look at power 3 and power 4. Okay, is there anything in common? Ask yourself this question. Alright, have, right? So if have, you can start to factorize out. And what do we factorize out? Do we factorize out 3 or 4? And okay, one more thing, when you factorize number 3, okay, you want to take this down in your notebook or your whatever, just make sure you know it by the end of the day. Take out the smallest one. Take out the smallest number. Okay, so what's the smallest number here? 3 and 4. Obviously 3, right? Actually, I can tell you why 3, because we draw a number line, yeah? Let's say this is from 1 to 10. Obviously, I'm not going to draw from 1 to 10, but yeah, sure, I can do that. Okay. So let's say this 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alright, and let me also add a 0 behind. Okay. So 3 is over here. 4 is over here. Usually towards 0 will be smaller. Of course, this is a primary school thing. Towards the left here, right, will be smaller. And then towards the right here will be bigger. Okay, so which is the smaller one? 3, obviously, right? So indeed, let's take out 3. And now, let's finally look at your fraction power. Half versus negative half. Okay. Stress already, right? So, take out the smallest number. Remember, keyword over here. Smallest. Actually, I have a better idea. Red means danger, right? Okay. Take out the smallest number. Alright. So, ask yourself this question. Between half and negative half, which is smaller? Because students usually get confused between positive and negative numbers. Like they'll think, oh, half is smaller or negative half is smaller. Okay, but who is correct? So, I'll draw a number line again, yeah? This time is from... So remember what I said? Anything towards 0 or below 0 is smaller, right? So you see, this will be bigger. This will be smaller. Okay, so usually what I will tell students is this. Okay, I will say, right, smallest number, and usually I will say to people who I'm teaching, okay, negative numbers are always smaller than positive numbers. Clear about that? I'm going step by step. I'm going very slow here. If you cannot just ask me, I'll be glad to answer them. Always. Keyword is always. Negative numbers are always smaller than positive numbers. Take out the smallest number. Remember that, yeah? So, between half and negative half, which is smaller? Alright, obviously, after what I told you, negative numbers are always smaller than positive numbers. Alright, I will take out negative half in this case, ladies and gentlemen. Alright. So, now, let's add in the things that we are short of. And you might wonder, why did I write a square bracket? I know inside I will have like that, dot. Alright, that's why I don't want to confuse myself. I'll write in square brackets. So, for the first term, what are we short of here? So notice 5x minus 1 cube and 5x minus 1 cube here. Match. Okay, so what are we short of? Put in your numbers first. 20. Alright. And then what will we put in? We will put in your 3x plus 2. One set. Why one set? Okay, let me tell you. Think about it. Okay, there's an invisible power here, remember? Alright, so remember this rule, a to the power of b times a to the power of c. This will be a b plus c. Alright, so ladies and gentlemen, look at this. Okay, now your a is 3x plus 2 negative half, and then your a is 3x plus 2. Okay, hold on. A in this case 3x plus 2, b in this case will be your negative half, then your times, right? And now your another a the same, your c is 1. So what is b plus c? Alright, okay, so this will be what? B plus c, right? So this will be equal to 3x plus 2 minus half plus 1. Type that in calculator, minus half plus 1. I can prove to you that you only need to bring in one set. That's just half. And as you can see, it matches here, here, and here. So that's why you see there's a 1 here and a 1 is here. You see that? So if all that I've said, that's why it's one set. And now we add the plus sign. Are we done with our first term? Yes. Okay. So let's start on with the second term. So now you notice 5x minus 1 cube and 5x minus 1 power 4. We will take in one more set, right? Using the same indices rule, 3 plus 1 is 4. And let me tell you, you are going to times this in. Therefore, it's a plus. Okay. The power number will plus. That's what I meant. Okay. So, let's continue. 5x minus 1. And now let's add in your constant 3 over 2. And do we have to deal with this? 3x plus 2 to the power of negative half and 3x plus 2 to the power of minus half? Match. No need. But what we are left, or what we are short of, is this one. Okay, and now we can finally close the bracket. Okay, so now I'll write it out like that. So that's the part that you asked for, and I already explained very clearly. If you have any questions, just text me, I will answer them. So let's expand the brackets here and here. Okay, so let's start. 20 times 3x, 60x. 20 times 2, 40. 5x times 3 over 2, positive, yeah? So 15 over 2, right? Positive 3 over 2 times minus 1. It's just a minus 3 over 2. Okay? So what's your answer? Okay. We will now simplify the x term together. 16 plus 50 over 2. Just type all in calculator. Don't need to be scared. Okay. And what is 40 minus 1.5 or 3 over 2? Plus 77 over 2. Okay. Oh, I should write in round brackets already. Okay. So now we notice that there's a power minus half here, right? So you see power number minus half, usually we will throw it to the denominator. How do I write it? Numerator first. So all your positive power numbers will all be at the numerator. Okay. So there are three ways which you can write your answer. I will show you the second way. The third way in green. Actually, there are 4 ways. I'll just share all of you, okay? Fourth way I write at the bottom here, in blue, okay? So you might wonder, why square root? So I'll explain the blue one first, okay? The red and the green, right? They are similar, but just that one I change to square root, one I leave it in positive index form. Okay? So I'll explain the blue one first. Why square root? Because remember, x to the power of half is square root x. 1 and 2 here. Okay? So now your x, just replace it with 3x plus 2, and you already have your answer. This is elementary mathematics indices, okay? Topic chapter 3 if I'm not wrong, okay? So, but for me, I leave it in pink, like that. Good enough already. So what if I leave my answer as improper fraction? Who cares? It's A math. Come on. Unless it's E math, then yeah lah. Okay, I change to mixed fraction lah. Okay, but yeah, I'll just leave it as improper fraction. If not, I can change to mixed fraction also can. And this one, why got 2 here? Okay, actually this one and this one, the red and the green, right? Reasoning wise is the same, just that the power half changed to square root only. And the 2 I will explain why. Okay, because this one I times 2 throughout. So of course this one I ignore lah, okay? So this one I ignore. And then this one I just times 2 times 2. Or if not what I did, right? Okay, I'll show you. So my final answer, I get this, right? What other color can I use? Okay, orange. So what I did was, this whole thing times 2. So I'll write out my product here. Whoa. And then you realize that I can split up the fraction, right? How do I split up? Okay, I'll just do for this term specifically. Okay, so for this term, we can say that this is a 1 over 2 bracket 135 x plus 77. Hold on, I'm just pressing my calculator to check. Okay, so remember this is a times, so this one come here, it means the same thing. It's like that, okay? So now with what? I'll just write the times there for better understanding. And now I bring it down to the denominator. My half, right? I bring it down here. So what that means? I press in calculator, half inverse. I get 2. And it works. Okay? So whenever you see a fraction, right? You want to bring it down, flip over. So let's say I have half at my numerator, right? So let's say I got half over 1. Can I say that this is the same? Now let me say I got half over x. Okay, can I say that this is the same as what? 1 over half over x. Can I say that this is the same as what? Half over x, right? It's the same as half divided by x. This is the same as what? Half times 1 over x. 1 over 2x. Can I say that this is 1 over 2x? Can, right? The 2 I just bring it down only, what? My number here is still the same, right? So that's why I write a 2 here. But actually this is only more for like if you want to like impress the marker or what. And the green one is the best way you can impress your marker. Why? You have cert form. And then you someone bring the 2 down. Why? You give the examiner an impression. Okay, I'm very smart. Okay? But honestly, if I were the candidate who take the O levels, final answer. Alright, so with that, I've come to the end of the video, and these are my 3 tips here as mentioned one more time. Number 1, look at your constants, which are numbers. Number 2, look at your x terms or unknown terms. And what do I mean? And then furthermore, look at positive whole number, which are power numbers. That means no fraction, no decimals. Okay? So that means what? If your x term got a positive power number, which are whole numbers, not fraction, look at that first. And number 3, take out the smallest number. Keyword smallest. And always remember this, negative numbers are always smaller than positive numbers. Alright, so with that, I'll leave it here. You can pause the video to copy. I know this is a 25-minute video. You can play at 2 times speed. I don't really care, but as long as you understand what I'm doing now and how to take out, yeah, I think you're good to go for differentiation. And thank you very much, everyone. I'll see you again.